Hi, all. So next we can illustrate a surface integral using a problem. So this is a problem. Calculate the surface integral of vector field V, which is equal to xzi plus x plus 2j plus y times z square minus 3k over the shaded sides of the cubical box shown below. Okay, so here there is one cubical box. Its side is 2. So all the sides would be 2. So we have to find the area integration or surface integration over these two surfaces. So there are two surfaces are shown here. Okay, so we can put this as surface A and this is surface B. Okay, so we have to perform this integration over these two surfaces. There are actually six surfaces, six faces for the cubical box, but here we are going to do only for two sides. Okay. So first we can do this integration over the face A. So surface integration is integral B dot integral V dot ds over the side A is equal to integral what is V, which is 2xzi cap plus x plus 2j cap plus y times z square minus 3k cap dot. Next we have to write ds. Okay, so here the first we have taken the face A. So in face A, a very small infinitesimal area, a small infinitesimal area can be represented like this. Okay, now for the face A, the z is constant. So the face A means z is constant, and actually this z is equal to 2 at that face. Okay, so in the surface A, the value of z would be 2. So z equal to 2 and it's a constant. So the only variation is for the x and y. So this side, so there are two sides for that infinitesimal area. So one side, this side we can denote by symbol dx and this side denoted by dy. So the area vector, the infinitesimal area vector ds would be the product of dx and dy. But this is a vector, so the vector should have a direction. Now the direction of area vector is always perpendicular to the surface. So there are two options here for the face A. So the perpendicular to the face A, the surface A means there is a possibility of upward vector or a downward vector. But by convention for a closed surface, the area vector is taken to be outward. So this is the outward vector and this is the inward vector. This is inward to the body. Okay. So by convention, the area vector is taken to be an outward vector. So this can be removed. So we will not use that. So the area vector is taken to be an outward vector. So therefore, the direction of area vector is along z direction, and hence this dx can be written as dx times dy times k cap. So therefore, dot dx dy times k cap. So this is at the surface A, and the surface A means z is already equal to 2. Okay. Now this dot product would give I dot k would be 0, j dot k is 0. So the dot product with the first and second term would be 0. And only third term would exist. So it would be y times z square minus 3 dx dy. But remember here z is already 2. So that we can substitute there. So z equal to 2 can be substituted. So it will become y times z square, that will be 4 minus 3 dx dy. So actually there are two integrations, so better we can put 2 integral here. So 2 integration. So it's equal to 4 minus 3 is just simply 1. So therefore it will be integral dx and integral y dy. So this integration I can split into two. One is integral over x, other one is integral over y. Okay. And we can put the limit also. So here the x varies from, for if you take the phase A, the value of x changes from 0 to 2 and y changes from 0 to 2. So the x and y we can put the limit. So x changes from 0 to 2 and y changes from 0 to 2. Okay, so the first integration would be x with the limit 0 to 2, and second one would be y square by 2, the limit 0 to 2. So the first one will become 2 minus 0 times 4 by 2 minus 0. So it will be 2 times 2. So the answer would be 4. So if you integrate v over the first surface, the answer is 4. So integral v dot ds over the surface A is 4. Now similarly we can find for B. Now for B, the thing is the y is fixed. Okay, so the plane B means the y is fixed. So at this surface, y is equal to 2. And what about the area vector? The area should be the outward to the, it's perpendicular to the plane and as well as outward to the object. So it should be along this direction. The area vector should be along this direction. So the area vector is directed along j cap. And what are the variables here? So if you take an infinitesimal area, so since y is fixed, so only two quantities would be changing here. One is x, other one is z. So this side is dx, this side is dz. So the x and z changes, and x varies from 0 to 2, and z varies from 0 to 2. So here the integral over the plane B or face B, v dot ds, we can expand. So there are two integration here. So 2xz I cap plus x plus 2 j cap plus y times z square minus 3 k cap dot dx dz times j cap. Now here the dot product with the first term and third term would cancel, that will become 0. So there are two integration. It would be x plus 2 times dx dz, and the limit x changes from 0 to 2 and y also changes from 0 to 2. So this integration can be split into two. The first can be integration with x times the second is integration with z. Okay, so integration with x would be x square by 2 plus 2x, limit is 0 to 2, and z limit is 0 to 2. So it would be 4 by 2 become 2 plus 4 times 2. So this will be 12. So the integral of v dot ds through the surface B is 12. So this is a way to calculate the area integration over the different surfaces. So here we have taken one of the simplest surface, that is the surface is of the shape of a square. Okay, so therefore the variation or the change in the variable is fixed. It is equal to the sides of the cube. So in case of the first plane, the plane A, the z is constant and x and y are changes, and the changes in x and y is from 0 to that the lower limit and upper limit are same. But if the shape is in the case of rectangle, then the variation in variable may not be the same. Okay, so the x variation, y variation would be different, so the limit would change. And obviously, if the shape is in the case of rectangle, sorry, in the case of triangle, then it will be slightly more complicated. The limit would be slightly more complicated. Okay, so the square or cube is the simple case, that is the upper limit and lower limit is independent on each variable. That is x variation is independent on y. But if you take the shape like this, for example, if the shape is like this kind of shape, suppose this is x-axis and it is y-axis. Okay, suppose this x varies from 0 to 1 and y changes from 0 to 2. Okay, so this is a case. Then okay, so the variation in x, okay, and we will put the limit. It can vary from 0 to 1 and y 0 to 2. But the limit in y depending upon x. Suppose if x is equal to 0, y can go from 0 to 2. But if x is in between, suppose if x is 0.5, then the value of y is limited. Okay, it cannot go from 0 to 2. Okay, so if you change x from 0 to 1, then the upper limit of y depending upon the value of x. Okay, so how we can find that limit? Okay, so suppose here, suppose we are integrating v dot ds in this area. Okay, so the area vector would be perpendicular. The area vector would be k. Okay, so now if you are putting the limit, okay, there will be some quantity vz, then dx dy, because ds is equal to dx dy times k cap. So v dot ds would take only the z component of v. So z component of v I am putting as vz times dx dy. Now when you are giving the limit, okay, if the x changes from 0 to 1, then the variation in y is limited. It cannot be taken as 0 to 2. That is not possible. Okay, so how will we fix that? For that, we have to find the equation for this straight line. So the equation for this straight line, we can find that y is equal to minus 2x plus 2. Okay, so we can just check it. That is when x is equal to 0, y equal to 2. That is valid here. And when x is equal to 1, y is 0. So when x is equal to 1, y is 0. So this is the equation. So this is a general equation, y is equal to mx plus c. So by just using the information of these 2 points, we can find this equation. So that's actually this point 1 means is 1 comma 0, and this is 0 comma 2. Okay, so that means the y changes from 0 to minus 2x plus 2. So this integration we can write like this, vz. First we can perform dy integration. After that we can perform x integration. So the y changes from 0 to minus 2x plus 2, and x changes from 0 to 1. Okay, so if the shape is not rectangle or not cubic, then the limit of one variable depend on the other variable. Otherwise, the limit would be independent. For example, in case of a square shape or a rectangle shape, Suppose if x running from 0 to 2, then y running from 0 to 2, it is independent. It is at all values of x, the y varies from 0 to 2. So whether x is equal to 0 or x is equal to 2, the y running from 0 to 2. Okay, so this is your x and this is your y. And suppose this is your x and this is y and it's a rectangle, and x this side is 1, this side is 2. Then at all values of x, y can take value from 0 to 2. So here the limit is independent. The limit of x and limit of y are independent. But if you take this kind of shapes, the rectangle or a circle, then the limit of x and y are not independent. Okay, so if it is a circle, then suppose if you take x is equal to okay, so suppose if you take x is equal to 0, then okay, this y take from this point to this point. So this can take all these values. Okay, let us assume the diameter is 3. So the y running from -3 to +3 when x is equal to 0. But when x is equal to 3, there is no change in y. But when x is equal to 1.5, then the variation in y is different. The y is not going from +3 to -3. Okay, so that is we have to keep in our mind when you are finding the area integrations. There will be two variables, and in general, the limit of one variable depend on the other. But there are special cases. There is the case of the square or rectangle. In those cases, the limits are independent. The x limit and y limit, or the variable limits, are independent to each other. But for all other shapes, whether you have taken triangle or circle, any other shape, the limits are dependent to each other. Okay, so that's all for the time being. So we have just illustrated how to calculate the surface integration using an example. So I am giving a small homework to you. Okay, so here I have calculated the area integration for the two faces A and B. Okay, you can find the same area integration for the other faces. Okay, so that I am giving as an homework. Find integral v dot ds for other four faces. So how will you do that? Okay, so only you have to choose one face at a time. Okay, suppose if you are taking this face now, the left side face. Now if it is left side face here, which is constant, the y is constant, is at this phase y is equal to 0. Y is fixed. And what is the direction of area vector? The area vector should be outward to the face and perpendicular to the face. Okay, so it should be along this direction. That direction is basically minus j cap direction. Okay, so the face B, the area vector is plus j cap, and for this face, okay, if you're calling that face is face C, it will be along minus j cap direction. The area vector minus j cap, and the y is constant, so the variables are x and z. So here the ds, we can write dx dz minus j cap, and since the shape is square, the limits of x and z are independent. The x varies from 0 to 2, and as well as z varies from 0 to 2. Okay, so that you can do it. It's very easy to perform, so you can do it yourself. So similarly perform all other phases as well. Okay, so I'm not giving any difficult example for you. So if you're going for square, sorry, if you're going for a triangle or a circle or any other arbitrary shapes, then the area vector, the area integration would be slightly difficult, as the limits of variables become intertwined. Okay, so that's all for the time being. So we have finished the discussion about the surface integral. So in the next class, we'll discuss about the volume integration using an example. So thanks for watching this video. See you later.